So we've learned quite a bit about Python already, and I wanted to start a project while introducing some new ideas and concepts. Um, and the project we're going to be working on is a ransomware project. It's going to start pretty basic, and it's going to evolve as we learn more about Python as well. So what we're going to be doing is a very basic ransomware, which will encrypt the hard drive. It will encrypt it with a particular key. It's going to send the normal ransomware message that it's been encrypted. You have to pay to a specific Bitcoin account. And then after successful payment, we can decrypt it and everything is going to work perfectly. Now, at first, what we're going to be doing today is looking at the basics of how the encryption is going to work, and this is not going to be too focused on encryption just yet, just how to make it in Python. So how to encrypt the file in Python, decrypt it, make a very simple fake encryption, so to speak, and work from there, and how to interact with the file system. But this is basically going to be what we're going to do today. And what we're going to do next week is going to look more into the network aspect of it, and we're going to develop from there. What's up, Diog? How are you doing? So hopefully people are happy with this project idea. We're probably going to make more projects as well. So I'm not sure if I went through the looping exercise before, but if we didn't, I'm going to go through right now. So just a little recap. We went through loops before. In the last week, we went through while loops and for loops, the break instruction as well, and we had a little exercise. This exercise was to create a function called addPrint that accepts one argument, which is a list of numbers. And this function should return the sum of all the values in the list plus 1 for each number. Okay, so this should return 14 because it's 1 plus 1 is 2, 2 plus 2 is 2 plus 1 is 3, so 2 plus 3 plus 4 plus 5, that would be 14. Okay, so to do this, you can write in here. I would usually write it in here, but you can see my screen, right? Yeah, you can. Awesome. But let's do this. So we need a function called addPrint, which is going to accept an argument, which is a list of numbers. So I'm just going to call it numList. And we can use what we learned from type hints by saying that this is a list, and it's a list of integers. Great. Actually, I'm not actually sure what Python version the server is running at. Maybe there are some things that can't be used yet. We'll see. In any case, what we can have is the sum list as equal to some kind of list, and we can iterate through the numbers. So for number in numList, we can wait. Oh, never mind. So the return value is each number in the list plus 1 summed together. So it's not a list that's returning. So the sum equals 0. And what we can do now is we can iterate through each number. So each of the times it's going to be, this number variable is going to be each number from the initial list. And we can add this value plus 1 to our total counter, right? So we can have a sum num plus equals our number plus 1. And we're going to return our sum num, and this should work. It only asks us to define the addPrint type object. Ooh, what did I do wrong in here? Did I do something stupid? Oh yeah, okay, I guess this does not exist yet. Let's just figure this out. Yeah, okay, this is correct. There was no, okay, so the problem is, it was introduced in a later version of Python, so I can still do this, right? And this will not fail the test, hopefully. If I have a decent version, it doesn't fail the test. But I don't know which Python version that was. I think maybe Python 3.9 changelog. Here. Yeah, here. See, it was Python 3.9. So in this release, it added a new feature called the type hinting generics in standard collection. So you can say things like type hint that it's a list and say that the list contains the string. But the version of Python that is being ran in this website is not yet 3.9. I have to update that. So yeah, so this is how it works. Hopefully this was clear. Now let's go into today's topic. I haven't added the article yet. I haven't written it yet actually, but I will do so right after this stream. It will be live maybe today, maybe still tomorrow. We'll see. In any way, we're going to. I have a little folder called projects inside of the Python fundamentals, which is open right now, and we're going to make a new project. It's going to be called Ransomware. Okay. There we go. Now I'm going to be using the command line for this to test this out. So projects, ransomware. I'm going to open a PowerShell here so I can run the code. It's going to be easier to visualize things. And I want to use a virtual environment. Now, what virtual environments are for is to basically isolate your Python environment with all the libraries that you install, and to isolate that into one tidy environment that you can destroy or use anytime you want without affecting your original Python installation. Now you can do this normally with a virtual env, or you can do this as a conda environment. I'm going to do it here as a conda environment. I will put the instructions on how to do it normally with the virtual environment in the text version of this. To have the conda environment, you just have to install Anaconda. I believe I covered this before. So I'm going to use Anaconda because that's what I have right now, and it allows me to install specific versions of Python as well that I don't need to have. And you can do so with Miniconda too. It's the same thing as Anaconda, just a little stripped down. You can just Google it and you can install it. And after you install it, I think I covered this before. After you installed it, if you do conda v, not conda v, but as long as conda shows up like this. Oh, it is big V. So big V, you know that it's working, and you can update conda as such, and you can install a new. You can create new environments by saying conda create and the name of your environment. So in this case, ransom. And then you can specify things like Python to be installed. And if you don't specify a version, it will install the latest version that it can find, in which case you see Python 3.9.1. So I'm just going to say yes. It's going to install it. Also, don't forget, if you're using PowerShell, after you install conda, if conda v doesn't work, or the very first thing you need to do is do a conda init, and then restart PowerShell. Anyway, so conda activate with ransom. Now it's activated. You don't see it activated. Normally you would see in parentheses here. You don't see it here because I altered the profile, so it only shows the last folder I'm in right now. But you would see it. And now I can use Python normally. Now you don't have to do a virtual environment. I prefer to do it, but you don't have to at all. You can use your normal Python installation. I will probably not be using almost any libraries at all. Only the standard ones, the built-in stuff. Anyway, let's just make a file called ransomware.py, and we're going to make some comments. So what do we need this to do? So we need this to encrypt files. We need this to decrypt files. We need this to show messages. Well, to show the message, we need to track payment, and we finally, and that's basically it. We're going to figure out more features of this in a later stage, but for now this is it. So we need to make a couple functions for this. So we're going to make a function called encrypt, which is going to take data, which is going to be the data that it's going to try to encrypt, and it will take a key if we need a key. Let's start without a key so we can get a feel for what we're doing. Now I'm going to use this keyword pass, by the way. This just doesn't do anything. It's just so it doesn't do an error. So if I do this, obviously that's an error because there's nothing inside of this definition of the function. A path just passes and does nothing. And we're going to do a decrypt with the data. And we're going to have some fun with this as well. Now, the first thing I want to tell you is how to actually read the data from a particular file, right? So let's create a file called mytext.txt, and we're going to have this is a great file. So how do we read from this file? Because obviously we need to read data from a file to be able to encrypt it, right? So the first thing we're going to do is we're going to use the open function. So if you have VS Code and if you have these tooltips, you can see some instructions for this open function. Now this can be a bit too verbose, but basically what this function does is it takes the file name, so this would be the file name. It takes another argument, which will be the mode. See here, so this is the file to be opened, this is the open text mode. So the mode is just if you're going to be opening in read mode, so you're just reading from the file, or if you're going to write to the file, or if you're going to append to the file. So if you go into read mode Python, well, actually it shows anyway, but yeah, it shows anyway. This was not what I wanted to put, but it shows here anyway. So the input and output, open, there we go, reading and writing files. So you have your open function, and if you click on it, you're going to have the full description. This is a bit better than the VS Code version. So yeah, blah blah. Okay, so you can see the available modes. So you have R for reading, that's the default if you don't specify anything. You have the W for writing, X for exclusive creation. You have all of the stuff that you can read. Anyway, if you do RB, for example, this is for read bytes. It's going to read it and it's going to treat it as bytes, right? And this is mostly what we want. We want to read bytes and write bytes. We will get away with R and W if we are using text files and simple things, but if we want to start reading binary data from executable files, then we're going to need to work with that, with the binary data, which is why we need to read and write as bytes. And that's basically it. So let's see what that looks like. So let's say file equals open. And what did I call this? My text. So mytext.txt. And we're going to open it as read. And what is this? So if we just print the file like this, and now we execute ransomware, we're going to have an object, which is a text IO wrapper with a name, a mode, and an encoding that adds automatically. This can be a different encoding for you. So this is the input-output object that's created when you use this function. You can do things with this object, such as read this object. So if we use the function .read, it's going to, and we print that, right? It's going to print the contents of it. In which case, this is great. This is a great enter file exclamation mark, which is what we had here. Now there are a couple of things you can do. You can do file.readlines, which is going to do the same thing, but instead of returning the whole thing as a string, it's going to return this in a list with each line in a particular list, right? You can also say read line, in which case it's going to read the first line. And if you look into more specifics of what you want to do here, you can read a particular amount of characters. You can do all sorts of stuff. However, for this purpose, we're going to focus on the read. Now, if you open this as read bytes, by the way, you'll notice you'll notice that this became a byte string. And you can see it's a byte string because it has the b pre-appended to this, and it has the rest. So this is a whole string. Dash r dash n, backslash r backslash n, that's the carriage return and new line. So this represents what happened between here and here, which was the new line. The carriage return just ensures that the cursor returns to the first position, and then it's a new line, so it returns to the beginning of a new line. Anyway, so this is the basic way of opening a file. Now here's the thing. When you open a file, you have to, so how do I explain this? We're going to go into a bit more detail when we talk about objects and how a lot of these things work. But for now, I think the best way to say this is that you're almost like opening a handle, opening a connection to that file. And if you don't close that connection, it stays open. So you want to close that connection. How do you close this connection? Well, if you search into here, there must be a close somewhere here. Oh, shit. Close file, Python. There we go. This is not it. I wanted to go into the actual docs, which appears to actually not be the easiest thing. So, okay, never mind. But okay, you can probably search through that. But anyway, you'll use the close method inside of this object, in which case it just closes the file. Now, it just opened and closed, so if we actually do a file.read, it prints the file.read. If you do a file.read again, it's going to say read of closed file, because you closed it here, right? So it's no longer open. And this obviously is useful if you're doing this with a lot of files. You don't want to keep the file open all the time. Now, there's a thing we can do to not have to close the file every time we open it. And this is using the with keyword here. So if we do with open, let's say mytext.txt as something, let's just say as f, and then colon, you can do anything inside of here while this is open. So this is very, you can see what this is doing because it's very readable, like English. So with this as something, do something, right? So in this case, we're going to print f.read, and you'll see that the result is the same. So this is a great file. Now after this, if I try to print f.read again, it doesn't work because it says I operation on closed file. So as soon as this with ends, so as soon as it comes out of the with group, it will close automatically. So by using this construct, you avoid having to always do like f.close and so on. So this is very useful. Now, what would be a way to encrypt this? We know how to open a file. Oh, by the way, how to write a file. Same thing, but instead of, so let's say created file.txt. Instead of using mode R, And by the way, I should have put mode R here for explicit, to be explicit, but the default is always R. Instead of using R, I can use W for write, as F. And now instead of f.read, I can do f.write. And again, I can write lines, in which case you can see here it takes lines, which is an iterable that contains a string. So if I have a list of ABC, DEF, so these are strings, this is a list of strings. If I use this and I run this, you'll see that a file called created file exists, and it's going to write this into it. It's just going to take the list and write everything into this as a string. Now, if you want to place breaks into here, of course, you can add a new line into here, do this, and ABC line DF. Now, a note for this. If you use the W here, this is creating a file. So if you have a file with this name already in it, and I'll show you in a bit. So remember our pass keyword from before that does nothing? I'm just going to use it here. As soon as you open this file with mode W, everything inside it gets erased. So if I do this, created file is now empty. I didn't write anything to it, I didn't delete anything, but as soon as I open with the write mode, it's going to get deleted. So if I do this again, it's going to write it into. Now, if you want to add more text into it without deleting everything, you can use A for append. So you do this, boom, it gets added again, A, B, C, D, E, F. So you do this again, it gets added into it. Easy enough to understand, right? Similarly, if you don't have a list, write into it, because you don't always have a list to write into it, you just want to write a string into it, you can use f.write, and now you can write a string into it with new lines or whatever. And oops. And when you write into this, well, maybe it's a good idea to erase everything else so we can show this. It writes into this. Okay, fair enough. Hopefully this was easy to follow, and I didn't do anything too crazy. If anyone is finding this a bit hard to follow, just tell me, and I'll try to explain it in a better way, or slow down a bit. But yeah, this is just basic input-output. There will be a document focused only on basic input-output as well after this stream is over. Do you upload all your streams on YouTube? Yes, I do. All of my live streams are uploaded to YouTube. I try my best to always cut the first portion, which is just the countdown for stream starting, and then have the live stream there. They have been quite long because a lot of the time I'm answering questions or doing other things. So I will. I decided to try maybe next week to go through all my live streams on YouTube and add little time segments to it, so you can see what is happening in each segment. So you can go to the segment that you wish to have, or bypass a specific segment. But that hasn't been done yet, unfortunately. But yes, everything is on YouTube. Okay. So from here, we know how to open files, we know how to read them, and how to write to files. Fair enough. So now what we want to do is to read a file, we want to encrypt it, and then we want to write that encrypted file there. And then we want to do the same thing for decryption. So how do we do this? Well, this is where the bytes are going to help us quite a bit, because we can just do this as text, but we're going to hit some problems when it comes to binary data, so executable files or even images and stuff. When it comes to any kind of data that is not a simple text, it will break if we don't treat it as bytes. And I can show you that in a bit as well. But let's try to figure out what kind of operations we could do. So if we have a string here, and I'm going to open my Python interactive terminal to show this. Oops, this is not what I wanted to do. Let's just begin with a clean slate. Okay, so a particular character is going to have a byte representation, right? So let's go with the character A. Right, so this is a string. Now, when you do something, I need to explain this. There is a function called ord and a function called chr for car. And let me just show you what they do in here. Ord Python, hopefully this opens up something interesting. Okay, let's just go with one of these. So it returns an integer representation, an integer representing the Unicode character. So in this case, ord 5 is going to be 53. Ord A is going to be 65, etc. And this is going to be very useful for us, because what we can do is we can do the reverse operation, so chr, for 65, which if we Google this as well, it's the reverse of, I might as well use the same thing I used before. So it returns a character from an integer, which is the exact opposite of ord. So with ord, you can see what number it can be the representation of a particular character. And with car, you can see what character that number would represent, right? So what we can do, for example, for a very basic way of encryption would be, let's take every single character, right? And let's see what the integer representation would be. So if we do, let's say the first one is t, so let's take the character t, and that would be 116. Okay. Now let's change this number. Let's add +1, for example, 117. And then see what character that would be. 117. That would be u. And then we would replace this with u, right? And do that for every single character. Then to decrypt, we have to do the same thing, except instead of adding 1 to each number, we subtract 1, right? This is a very easy way to go about this. Let's try to do this. So we have some data, and let's say this data is a string. So we're going to do for character in data. Now let's just print the character for now, right? And what we're going to do is we're going to say that data equals, let's be coherent with our use of with. So with open mytext.txt as f in reading mode, that is going to be equal to f.read. So being explicit with what we're doing. Okay. Now we're going to use encrypt. We're going to pass in data. Oops. Encrypt and pass in data. Now if we run this, there we go. We're printing every single character, right? So THIS, this is a great file, whatever, right? Now, let's print the ord of this character, which is the integer representation of this character. There we go. Now what we can do is we can have our num list, for example, right? And we're going to append this integer representation to this list, and we're going to print the num list at the end. Right? So if we do this, we're going to have a list of all the numbers that can be converted into the characters that we've just seen. Instead of only appending this, I can append this +1, for example, right? Now all these characters have changed. Okay, this is an interesting thing to do. So instead of printing this, let's return this. So now encrypted list equals this. So our encrypted list is now a list of all the integer representations of the characters in the original text plus 1. So it's a bit changed. Now let's decrypt it, which is decrypt of the decryption of the encrypted list. Right now, to decrypt this, it's pretty easy as well. So we're just going to copy paste this because it's going to be the same thing, except we're going to subtract 1 instead of adding 1, because that's the opposite of what we did before. So, and now what we can do is we can print the encrypted list and we can print the decrypted list. And I'm going to use F-formatted strings, and I'm going to use an equal sign here. I believe I explained this before. Let's just check if I did. I didn't. Did I? I didn't explain output properly yet. Well, I will. Okay. Let's forget this equal then. Let's just print both of these. So when we print both of these, oops, what did I do? Oh, I'm an idiot, of course. We have already integers, so we don't want the ORD, we want the CHR, right? Obviously. So this is my text, this is a great file. Oh god. Line 16, what happened in line 16? Something bad. Oh, I'm an idiot. Yes, of course. Yeah, so the character is already an integer, so we want to subtract 1 to it and then have the character representation of it. Okay, there we go. Now we got our little list, this is a great file. But now, of course, this is a list of all the characters. We want to make this into a string because that's what we had before, right? How do we make this into a string? Well, we can use the join function. So, by the way, Python join. Whatever. Let's just use this, for example. So a join is a method that you can use from a string object. So you can have a string dot join and then any kind of iterable inside. What will this do? So let me just explain this really quickly. So if you have, for example, a list called A, and it has, let's say, numbers. Wait, it's not a good example. Oh, sure, okay, 1, 2, 3, 4. Okay. Now, if you print A, it's just going to be a list 1, 2, 3, 4. Now, if you want to make this into a string, you can do double slash, so it's a string dot join, and then the iterable, so A. Now, this of course needs to be oh my god, I'm a string, right? Because this is a string. So how we do this? Obviously, we can. I haven't talked about this yet, have I? Okay, you know what? Let's change A to be 1, 2, 3, and then 4, 5, 6. So a string, right? Now, if we do this, we'll get a string with all of these joined together. That's what join does. It joins elements, string elements of a list. So, well, what if I want to join these with a little dash? Well, you can do a dash here, and then we're joining them with a little dash. So for each element. If we want a space, you can do a space too. And notice we can have as many elements as we want, right? Oops. So now if I do, I can even do like a new line dot join A, right? And this will put a new line for every element. So that's all we're doing. And because we have a string in each element, we want to join it. So we do a join, so with no characters, so it's just all the strings together. And now, if we run this, we're going to have our encrypted list, and then we're going to have our decrypted list, which is going to be, this is a great file. So if we just print our decrypted list with nothing else, we're going to have this as a great file again. Easy. So we encrypted and we decrypted a file. Now let's go a step further, okay? And do another function called encrypt file, file name, and the same thing for decrypting a file. So decrypt file. Okay. So what we're going to be doing is with open, well, it's called data equals, I'll use the same expression I used before, just for consistency. So now we have data, which is the file name .read, so we have our data. So it's the same thing as we did here. We don't need this anymore. And perfect. And now we need to encrypt this file. So encrypted is going to be equal to encrypt, and we're going to pass the data. Now we're going to receive the encrypted data. Now how do we write the file? The file. Well, we're going to open it again in W mode as F. This F gets tossed out as soon as the with ends, so it doesn't really matter that we use F again. We're now going to f.write this encrypted version. Now here's the thing. The encryption gives you a list of numbers, and that's okay. But we wanted to give something that I can put into the file, so bytes. So just like in the decrypt, we used the join function. What we're going to be doing is we're going to do this in the decrypt function already. Okay. So this was what we used. So if we do this, boom, this is going to return already the formatted string, right? And in the same way, we want the encrypted data to do the same. So how do we make that happen? Well, we need to convert this back into a character. So this is a number. So let's do something different. So let's do car number equals this, plus 1, because we're encrypting it. Now, the actual character is going to be the CHR applied to this number, right? So car num. So we're going to append the actual character. But we also need to change the decrypt because now it's expecting a number. It's no longer a number, it's a character. So what we're going to do is car number equals, well, ORed is the reverse of CHR. So if we do OR on character, it's going to give us the number of the character. We need to do -1. So now we need the CHR of car num. Perfect. So this should still work. And now we're going to go on to the encrypted file, and we can directly write the encrypted, because now it's a string. Right? Because, oh, is it a string? Did I? No, I did not. So I need to join this, of course, because it's still a list, right? So we join this. Now it's a string. Perfect. So now I can call this function, encrypt file, with the file name mytext.txt. And now when I call this, it's going to open it. It's going to read it into the variable data. It's going to set a variable called encrypted, which is going to execute the function encrypt with this data. The encrypt is going to change all the characters by its integer representation +1, convert it back to character, and return the string. And then we're going to open the file name and write that string into it. So this is the file. If I run this, oop, there we go. It finished, and this is completely bogus. We cannot understand what this is anymore. Now, if I decrypt it, which is going to be the exact same thing, so I'm just going to copy everything and paste everything. It's the same thing, but let's call this decrypted. And of course, this is going to be decrypt. So decrypted. And now if we decrypt the file, there we go. It comes back into this is great file. Awesome. Now this works pretty decently, right? But the problem is, let's go find here. So we have this executable called uninstalled.exe, right? Now if we try to open this, it represents a lot of non-printable characters because this is binary data and not all possible bytes are representable on this screen, so that's why there are question marks in here and little boxes. And if we try to do this with our uninstall.exe, and let's encrypt. Now let's make sure that it runs, by the way. So if I double click this, it runs. Right? I'm not going to uninstall it, but it runs. Now if we execute this, there's going to be an error. That's the first thing. Unicode decode error, in which the Carmap codec cannot decode byte 0x90, maps to undefined. Yeah. Why? Well, bytes are, well, they're numbers, right? And let's look up a Unicode table here. Sure, why not? There we go. Okay, so where is our, what is this, CP1252, which I think, oh, actually this is really helpful. Look, so here we have our Unicode table, which has a range from 0000 to 007F. This is the range of, well, represented in hexadecimal, but it's the range of all the characters that are able to be represented by these bytes, right? So if I put a number that is not within this range, it doesn't know what to do with it because it's not convertible into that particular encoding, which is, oh, this is the same thing, okay. Which is the whole idea. So, for example, let's do, let's go into Python interactive shell, and this is something I can do a bit better. So ABC, this is a string, right? Now if we encode this using the .encode for string, so it's any kind of string .encode is going to encode it into a byte object, into a byte string, but it's going to use a particular encoding, obviously, right? Because it needs to be able to be representable when you print it. And the encoder that it's going to be using, how do you specify encoding here again? I haven't done this in here in a very long time. Oh, there we go. So it's just the argument for this. So it's going to be UTF-8 encoding. If you do UTF-16, it's going to show a different representation. And this is what is really important to realize. Now, if we do, and of course, this is when we're working with bytes, right? But here's the thing. So let's say we have b equals this, right? So this is the byte string that we have, and we want to decode this. This will not work because the codec cannot decode this particular byte. It doesn't exist because UTF-8 character table does not have the FF byte in there if you look into it. Yeah, okay, it actually already says it in here. There we go. So hex, there we go. So you'd go, so 7E, 7F, C2, 80. Right? So FF is not a UTF-8. It cannot decode in this position because the UTF-8 hexadecimal value does not exist for FF, right? Okay, so how do we make this happen? Well, if we type UTF-16 in here, this will work, right? I wonder if there's a UTF-16. No, okay. Oops. There we go. So we have a little UTF-16 table. Okay. So in here, we're going to have our FF. Awesome. Okay. That's the idea that you can extrapolate from this. Now, of course, you have to find the particular and this is a bit tricky actually with Python, because you need to figure out what encoding it's using when it reads. So for example, when we're doing the reading of the file and the writing to the file, we noticed, even in the error notice, we noticed that it's the CP1252 encoding, right? And the 0x90 byte does not exist, so it doesn't map to a defined thing. So how do we take care of this? Well, these files are obviously reading bytes, right? So we need to treat this as bytes. So instead of reading the data normally with R, we need to read it as RB, as bytes. Okay. Now something interesting happens when we read this as bytes, and we have to change our code accordingly. So let's say we have a byte string. So a byte string starts with a B. I think we covered this before in data types, perhaps. Oh, no, we did not. Wait, where did we cover this? Did we cover this? I should really make sure that I know if we covered this or not. Oh, okay, yeah, we kind of covered that. Okay, we kind of covered it. Okay, I will add another section for these. So I'm gonna make a little file here. So add basic IO, add string formatting. Yeah, this is it. Okay. So yeah, so to define something as bytes, you just have to put a B and then a string, so the double quotes, whatever it is inside, this will be a byte string, right? If we do a type A, this is bytes. Awesome. So if we have, let's say, hello world, right? Now, this, of course, if you do type A, bytes, A. Now, if you do A0, it's going to give you a number. It's not giving you the byte, it's giving you a number. What is this number? Well, if you remember the ORD and the char thing before, where the ORD you can get the numerical value of a particular character, and the char you can get the character of that particular value. Well, if you use char on 72, you're going to have H. Now H is this letter here, right? Now A1 would be 101, which is E. So if we do char 101, that's E. So when you iterate through a byte string, you're going to get the integer representation of that particular byte. Now what can we do with this? Pretty easy. So what we can do with this is, since we're getting the number representation of that particular byte, we can just add or subtract 1 from that particular byte to transfer it into a different byte, right? It sounds easy. So, and this is why I'm going to introduce to you into a byte array. So we know we have bytes type, which, by the way, it takes an iterable where you can place numbers inside. So if you have number 41, 42, 43. Perfect. Now what I actually wanted to do is this, because, and as you're going to see this later, this would be ABC. Okay. But we can put numbers into here, right? And these numbers are then going to be, we're going to have a bytes object, which is an immutable object, right? And we can use this to group up all our bytes together based on these numbers. So it's going to be just an easy way to place the numbers into this and get our byte object. We also have a byte array, which is the same thing. Okay, a byte array is basically the same thing as a byte object. The only difference is a bytes object is immutable, so you cannot change it, right? So if you do something like, so we know that A is bytes. If we say type B, it's a byte array. So the difference is going to sound apparent when I say b.append 1. Now if we print B, it's going to have a byte array with the byte 0, 1, right? If we do append 2, it's going to have 0, 1, 0, 2. Great. Now if I do a.append 1, it tells me it has no attribute append. If I check for the first element of A, which is 65, because it's the number, again, character 65 is going to be capital A. If we print, that's the first element. Now if I try to change this, this is going to be equal to 2. Does not support item assignment. It's not mutable, right? And if we do this for B, it changed this. Right now it's 2. If we do 3, 4, whatever, then the first element is 4. So the difference between a byte array and a bytes object is that the byte array will is basically is mutable. So you can append to it and you can change the items, while a bytes object does not change. You cannot change it. Okay, so how is this going to be useful? Well, we can create a byte array. So let's delete our encrypt here. So we can create encrypted, which is going to be a byte array, right? Now, for character in data, now remember that when we iterate over a byte string, so if we have a byte string A equals to hello world, right? Now I'm going to, for I in A, so I'm iterating through it, I'm going to print I. It's not going to print H and E and L. It's going to print the numbers representing it, right? And this is going to be useful because car here is going to be the number. We can essentially already add to this array these numbers plus 1. So we can do encrypted dot append car plus 1. Easy, right? Okay. And for the decrypt, we can do the exact same thing, except, well, it's going to be decrypted, and we're going to decrypt it append, and then we can return decrypted, right? And then we can return encrypted, right? So now we're going to have a bytes object. So in our encrypt and decrypt files, this is not going to be a bytes object. So now we have to write bytes into this. So WB for write bytes. We're going to write the encrypted bytes. Easy. Same thing for the decrypt. We're going to write bytes and we're going to read bytes. Great. So now let's try this with the uninstall.exe. Now to make sure that it works, I'm going to open this up and it's working. Okay. very important error, by the way. It's also something I wanted to talk to you today. It says value error, byte must be in range 0 to 256. Where is this happening? This is happening here. Well, it might be happening here too because I'm an idiot and did not change this. So for decrypt, it's -1, obviously, right? But it's happening here, or there before, but yeah, it doesn't matter. Why is this happening? Well, this is happening because when we have a byte array, so let's say that A equals a byte array, right? And now I'm going to append the byte 2, right? I print A, it has 0x02. Perfect. We're going to append 100. That's 02D because this is hexadecimal. Well, yeah. I should have. Okay, I'm going into this in a bit. I just want you to understand that this is actually happening. So this, of course, is hexadecimal notation. So when I do 200, yeah, it keeps appending to this. But as soon as I do 256, it tells me that it has to be between 0 and 256. Because that's the range of the byte, right? A byte needs to be between the values of 0 and 256. Why? Well, this comes back to what a byte is, right? And what different bases are. So we're used to working with, I can't believe I'm going to use Paint for this, but I don't have my usual things. Maybe this works. Okay, this kind of works. Oops, I'm an idiot. Yes. Oops. You know what? Let's just use a new one because I'm a idiot when it comes to stuff like this. Okay, so well, when you have a normal number, so let's say you have a number 30, right? This is decimal 30, right? So this is base 10. What does that mean? Well, we know what binary is, right? So what is binary? There's probably a better way to do this, but I'm doing it in this way. So what is binary? Binary is a number system that works with two possible numbers, 1 or 0, right? Something is either 1 or it's 0. And you can have numbers 1, 0, 1, 0, 0, etc. But the number, for example, 12, is not valid in binary because there is no number 2 in binary, right? So that is why it's called binary. It's base 2 system. So a base 2 numbering system means that it's a whole number system composed of only two possible numbers. In this case, 0 and 1. This would be base 2, right? Now if we go to base 3, which we don't really use, but if we were to use base 3, we would have numbers 0, numbers 1, and numbers 2. Now, and it's 3 because there are 3 numbers in total, so 0, 1, and 2. Now, when we go into base, for example, 10, which is the base we're usually used to working with, we only have numbers 0 through 9. So if we add them, so 0 plus 1 plus 2, etc., until 9, that's 10 digits. That's why it's called base 10. 0s through 9. And that's all the numbers that we use. Now, in base 16, we use 16 different numbers. So from 0 to something, right? But here's the thing. We cannot, we have to have a different way of representing a single digit because it goes into 16 and our numbering system fails at this. So that's why we have letters, so from 0 to F. So maybe it's easier. So for normal decimal numbers, you have 0, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then as soon as you want to represent anything greater than this, you have to use 2 digits. 10, right? 1 and 0, right? In hexadecimal, this is base 10. And hopefully you can see this. I know I'm probably explaining something that you guys are very familiar with already, but anyway. Now, for base 16, things are a bit different because we still have 0 and 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9. But we need to have more numbers before we start combining these, right? And we can't use 10 because this would be a combination of these. So we have to use other letters. In this case, A, B, C, D, E, and F. Why does it go until F? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is 16 digits in total. If we want to represent anything after F, we have to start using other numbers. So after F, we'll go for 10 is the number, right? So this is how bases work. And if we were working in base 2, which is binary, we have 0 and we have 1. We don't have 2, right? So to represent 2, we'd have to do 10, right? And this is the letters you're seeing here, right? So /x is the notation for hexadecimal, and you have 02, DD, etc., right? 0x, so CH, etc. Now, the reason why bytes are each byte needs to be a maximum of 200 from 0 to 256 is because that's the value of the highest possible byte, which is FF. So if you just type 0xFF, which is FF in hexadecimal, which is the largest 2 digits that you can have in hexadecimal, this is 255. So now if we include 0, in total that's 256 digits. So again, 8 out of 10 to 156 doesn't work. You have to do 255, right? Because that's the last possible byte. Now, why is 0xFF a byte? Well, what is a byte, right? A byte is a sequence of 8 bits. So if we look into this, so byte, oops, there's probably a definition of a byte somewhere, right? So yeah, it commonly consists of 8 bits. So bits are either 0 or 1. Bits is a short for binary digit. So again, binary base 2, bits. So bits can either be 0 or 1, right? So a sequence of 8 bits goes from 0, 0, 0, so 1, 2, 3, 4, 5, 6, 7, 8, into this, right? Now, if we convert this, and we can convert this using the int function. The int function converts a string, let's say, well, this number, and this is converted into integer, as you already know, right? But you can specify a particular base. So if we do base 2, this converts this, this treats this as a base 2 and converts it into a base 10 integer, which would be 255. And this is 8 bits. And since 255 is the highest byte that you can possibly have, well, that's the range of the byte. It goes from 0 to 255. That's basically it. And 255, of course, is FF in hexadecimal. So if we do FF here, and you put 16, because hexadecimal is base 16, we get to 155, right? So if this goes from, so let's go back into this. So if this goes from 0 to 255, we cannot, when we do the +1, right, we need to make sure that it's within the range of 0 to 256, 255 inclusive. So what we can do is, well, we can have this character +1, and we can use the mod of 256. What is this going to do? So if we have, say, again, in our append 256, this doesn't work, but if we do 256 mod 256, it will work. And it's 0, by the way. So what the modulo does, by the way, I'm 100% sure that the modulo was here before. Arithmetic operators, blah, blah. Modulus operator. There we go. the module is something else, never mind. So the modulus operator, it takes the remainder of a particular division. So if you divide 5 by 4, it's 1.75, but if we take the remainder, it's 1. And this remainder is essentially going to be what the number 5 looks like if there are only 4 possible restricted to the range between 0 and 4. Let me give you an example. So let's say that you can only have numbers from 0 to 4. So 0, 1, 2, 3, and from 0 to 4, non-inclusive 4. So only from 0, 1, 2, and 3, right? Now we have the number 5. Where does 5 fit in here? Well, it's 0, 1, 2, 3, then it goes back down, 4, 5, that's 1. So mod 4 equals 1. Now if we do 6 mod 4, it's going to be 2. Because again, so we have 0, 1, 2, 3, 4, 5, 6, which is 2. And again and again and again, right? So this is limiting it to a particular numbering system, which goes maximum to 256, and then just goes back around. So if we do the exact same thing for here too, although here we need it for both sides, and you'll see why in a minute, or you might not, but there we go. So if we do this now, we're no longer going to have the error that it's that the byte is not in range, because we're limiting it to that range. So let's try this again. Let's make sure, by the way, that our install still works, as it does work. Now let's run this. It ran, apparently. Now if I try to click it, it doesn't work anymore, because we've encrypted it. Now if we decrypt it, we double click it, it works again. Perfect. So we can now encrypt and decrypt files. Great. How about we encrypt a directory, right? Because let's so we can encrypt data. Perfect. Decrypt data. This is the basics of it. Now encrypt the file. That's good. Decrypt the file. That's awesome. Now we need to figure out how to encrypt the directory, because in a ransomware we want to go into a particular directory and just decrypt every single thing inside of it recursively, right? So how do we do this? Well, we can use a very useful module called OS. This is built in. It's very useful. What OS provides us is with the os.walk. And so let's declare a new function. So encrypt directory, your name, and let's have the same thing for decrypt the directory, which will just work in the same way, but the opposite way. So we need a way to list every single file in a directory so that we can put this file into this encrypt file and encrypt it, right? Okay, great. For this, we're going to create some test stuff, okay? So we're going to create a new directory called test. This is, so, you know, to prevent running this into a directory that is important and might override stuff I don't need. This is a testing directory. So inside of here, everything will be encrypted. This is basically the C drive. So let's create some files in here. So I'm going to create a secret.txt. We're going to put it some information such as bank details. We're going to also create another file called, I don't know, passwords, super secure pass 1, 2, 3, doesn't matter. Okay, now let's create a new folder in here, prawn folder, in which we're going to have prawn images, and we're going to also have prawn accounts, and I'm going to put account 1, password 1, images, and I'm actually going to copy this uninstall.exe into our prawn images just because I don't have an image handy here. I could just Google an image. In fact, let's just do this. Cat cute images. There we go. So we're going to save image as, we're going to go to documents, books, Python fundamentals, projects, ransomware, test, prawn folder, prawn images, and do some excessive prawn. Okay, so let me just cut this out and place this in another folder called executables and paste this in here. Whatever. So now we have a little test place where we have some files that are definitely super secret files that we don't want anyone to ever get to ever encrypt. We have some images, so we can prove that these images still work afterwards. Now we know where his prawn folder is stored. Exactly. So so how do we go about encrypting this whole directory? So in this encrypt directory definition, we're going to have a directory name, and in this case what we're just going to do is print out our os.walk dir name, just so you know what os.walk does. So os, the name of the module, walk is a function that exists within it, and it takes a name, and we're going to see what it does. Now we need to execute this, right? So let's encrypt directory, and let's use this name. So test, I believe it's called test, right? Test, yeah. And by the way, this is going to be relative from where you start the application. So I'm starting it here, so it's going to see the test. If I went into test, obviously it would look for a test inside of here. So when this is executed in the context of any folder that you want to start using absolute paths. You want to start using absolute paths, obviously, right? And extracting paths from environment variables like user profile, etc. So, but for now we're going to use these relative paths, and we're going to look into how to transform everything into absolute paths in a later stage. This is just for testing purposes right now. So if we execute this, so it's called ransomware, we see that this is a generator object, and we haven't really touched into generator objects, which is something that I'll also add into here. So add generators, and what generator objects are is they're basically a cheap way to produce items that would otherwise be not necessarily, but it's basically an alternative to having a list of them. You can have a generator object that computes each iteration of something and gives you that value without having a list that stores all those particular items inside. Let's look at an example of what a generator looks like, by the way. So a generator, you can, for example, have I for I in range 10, right? 10. If you see what A is, it's a generator object, right? Now, if you type len A, it has no length, right? What's going to happen is each time you get into the next being, have something huge, right? If this was a list, by the way, see how long it's taking to get this from a list. It's going to take a long time, and it's not really going to be helpful. But if we do this as a generator, we can just do next A, and this is how you iterate through generators. You just type next A, 0, 1. Again, I for I in range, blah, blah. So 3, 4, 5, 6, etc. Right? And you just next it until the end. And by the way, what happens in the end, it throws stop iterator. So stop iteration. So let's do range 10, so it's simple. So let's do a while true, print next a, and there we go, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then stop iteration is reached because the iterator cannot go further. Perfect. So this is basically how iterators work. I will add another module, as I've noted here, specifically for generators. Sorry, I said iterators before. For generators and how to use them efficiently, when to use them, all sorts of stuff. But for now, let's just remember that os.walk returns a generator. Right? And how do we iterate through generators? Well, we can use next, for example. So if I just do a while true, it's going to immediately exit as soon as, oops, I need to print this. So print. It's going to exit as soon as the stop iteration exception is reached. Oops, I'm an idiot. No, I'm not an idiot. Oh, I see. Okay. Fine. Because this doesn't actually reach a stop iteration, does it? Okay. Let's do this in a different way. It doesn't reach it doesn't matter. Let's do this in a different way. We can transform this. So for item in os.walk dir name, so we're going to iterate over it normally. You can also iterate over it normally, of course. So again, using our later example of for I in range 10, generate exception. So for I in A, print I. This is still going to print everything up until when it runs out of things to do. Now, we're going to do the same thing, but printing the item that this returns. So we can see what it returns. And this is really, really helpful because it returns everything. So we see here test, then a list of folders. So if we come back here, inside of our test, we can see that this is correct. So inside of test, we have, so the first thing that it returns, so it returns a tuple of things, right? And inside of here, there are 3 items. The first one is the folder that you're currently in. Thank you for the follow, Jazz10. And the folder that you're currently in is going to be listed, it's going to have its folders listed in the next item. In this case, we have executables here and prompt folder here. And then it has all the files inside of it, masters.txt, secret.txt. And then it's going to go through all of the folders inside of test. So again, the current folder, test executables, let's open this up. The folders inside of it, it doesn't exist, so empty list, and the files, uninstall. Great. Next one, we have a prawn folder. So test prawn folder. And it has 1 folder, prawn images, and 1 file. Now test prawn folder, prawn images, so here we have our image. There are no folders, so empty list, and there our image. So this is a way to return every single file that exists recursively inside of a directory, and inside of the directories of those directories. Now, we're not actually concerned with the folders that exist inside of each folder, because they're going to be the files inside of it are going to be listed anyway. So what we can do is first we can define the 3 things that are going to be appearing here. So we're going to have our root directory. It's just going to say root path, whatever. This is something we don't care about, and then we're going to have our file name. Right? Let's just call it path, so it's just a bit easier. So now if we print path, and of course this and file name, it will be the exact same thing. Well, basically what we're doing here is we are unpacking this. And I'm not sure if I showed you this before, but I will. You can do things like this. For example, if you have, say, b equals a list, and this list has 3 elements, right? 1, 5, and 4. Now you can say I, j, and k equal to b. What does this mean? Well, it's going to take b. So if you print I, it's going to be 1. If you print j, it's going to be 5. If you print k, it's going to be 4. What this is going to do is it's going to take this list, and it's going to see how many items this list has. And it's going to divide those items by the number of, it's called unpacking. It's going to unpack those into the variables that you explicitly presented. Now, of course, if you only have 2 of these, it's going to be an error, a value error, because it says too many values to unpack, obviously, because you have 3 values and you're expecting it to unpack on only 2, right? Oops. No. Yeah, so you need like all the values to unpack it, obviously, right? And there are a couple tricks we can take care of for this, that we can use for this, and I'm gonna tell you about those in a bit at some point. But for now, just remember, we're just doing a little shortcut where we are unpacking this. So when I say for path, and I can say folders, doesn't matter, and file name in here, what it's going to do is it's going to take a look at each element of this. Oh my God! It's going to look at each element of this, and it's going to divide whatever's inside of it for these 3 variables, right? And because we always have these 3 variables, it works. Now I'm going to put an underscore here because it's convention. It just means we don't care about that. And we're just going to print the path into file name. Oops. And the reason we don't care about the folders is because we're going to always have our path equal to, test and test executables, test print folder. We're always going to go through all the folders anyway, and we're always going to have a list of the files inside of those folders. So I'm going to call this files. So what we can actually do is we can iterate, because this is going to be a list, right? Even if there's only 1, it's going to be a list. So we can iterate for file in files, and now we can just print. I'm going to use formatted strings to print the path / the files. Okay, there we go. Oops. Oh, sorry. File, not files. There we go. And now we're printing every single file that exists in those directories recursively. So test passwords, and we can see this happening, right? So test passwords exists, test secret exists, text executable uninstall exists, text prawn folder, prawn accounts, and prawn images excessive prawn. Right, this exists. Perfect. So we now have a way to basically list all of our files. So our file name is going to be this, basically. We're giving the full path to the file name from where we are. Now what we want to do is we want to encrypt that file, right? So we encrypt file name. And after we encrypt this file, well, that's it. It's encrypted. Now we're going to do the exact same thing for the decrypt, except it's decrypt file instead of encrypt. And this is the usefulness of already having, the encrypt file and encrypt data functions, because we can just reuse them, and it's really simple functions. Now if we encrypt directory test, let's see what happens when we do this. Just encrypting, not decrypting. No errors, already done, that was fast. Now, nothing seems changed. However, if I open secret, this is something we didn't put in here before. If I open passwords, you can't read this. If I open prawn folder, prawn accounts, you can't read this either. This does not open as an image anymore. And executables, this does not work anymore, because it's encrypted, of course. What's the reason for the key in ransomware to unlock, as you could write a decryption file to decrypt the files, or isn't that easy? Wait, let me read that again. What's the reason for the key in ransomware to unlock, as you could write a decryption file to decrypt the files, or isn't it that easy? Okay, I'm not entirely sure what you're asking, but I'm going to tell you something that might clear this up. So, the way we are encrypting these files, so if we go into our encrypt function, we are simply just taking each byte of the file. So if we go into, any file, we're taking each byte, in which case it's each character representation. We're getting its number value, so it's byte value, and we're adding 1, and then we're putting it back. So this is a very simple modification, right? You can just write a thing to do the same thing, but in the reverse order, and that's simple. Now, this is just for show. I'm going to show you how to create a very simple key as well that works on the same principle, but that might be a bit harder to reverse. But yes, if you know exactly how it was encrypted, you can reverse it. Well, kinda. Because using these simple methods, of course, you can just reverse the whole process. However, and this is a really good question, because it's encryption, right? And I wasn't going to get too much into it, but so think about it like this, just for a little intuitive understanding. If I tell you that, let's say you have number 14, right? 14 is the number you want to encrypt, right? And I tell you that, I have an encryption that encrypts this and just adds 5, right? It becomes 19. Now this is easy to reverse. If you know that it adds 5, you just subtract 5 and it becomes 14, right? Now, here's the thing. If I have, let's say, how do I put this in a better position? So, okay, so here's the idea. If you have a sequence of numbers that is multiplied together, so let's say you have 4 times 3 plus 17 minus 1 divided by 2 plus times 4. This is 27. Awesome. Now, if you have the number 27, can you tell me how I got to it? You can't, right? Because we did a sort of a wide range of operations that are really easy to compute, right? This takes like a second. But reversing all the possibilities for how we could make this number happen isn't possible. Well, of course it's possible here, but in your mind it's not possible, right? So, because obviously this can be 20 plus 7, right? Or it could be 19 plus 8, or it can be 2 times 5 plus 3 times 5 plus 2, right? It can be anything. So, and this is kind of the idea with encryption, where you're trying to apply a particular function to a particular sequence of modifications that you cannot reverse easily. So you cannot tell that what were the operations that were done to get to it, right? And obviously here it's pretty easy to tell because it's a very simple operation. But when you start going into other algorithms, and I'm going to make a specific thing about encryption when we, during the whole process of the ransomware, because we're going to apply some seriously nice encryption to make sure that it cannot be easily reversed or at all. The idea is that you make a function that applies a modification that, if you were to try to reverse it, it would take too long to, or almost be impossible, right? So with this example right here, right, computing this is really easy. You type it in and boom. But let's say that you know that this is A times B plus C minus D divided by E times F, right? Now, if you make a function that tries to figure out what numbers have to go into here to give the number 27, it's going to take you a while, right? And you might find more than one correct answer. And here's the thing. If you find 5 correct answers, right, then sure, you have found another answer that can solve the problem as well. And that's another key point of encryption, which makes it so that, and when we go into the algorithms, we're going to see this in a bit, which makes it so it's very difficult to actually create a collision or create a different set of inputs that actually get the exact same output. So this is the basics. So imagine this, but a much more complicated operation that the computer cannot easily reverse. It takes a lot of computing power to reverse it. And that's why, of course, encryption works. But right now, this is going to be a very simple encryption that you know how it works, you can reverse it. Right? In a bit, even in this video, in a bit, I'm going to add a little key so that even if you know how it works, you need the key. Or you can brute force the key, but you know, if you use larger keys, you can still brute force it, but it might take you a little bit longer. So we can get the gist of how to protect us better. Did this answer your question, kind of, or do you still have any doubts? Yeah. Okay, that's awesome. So so let's just finish this part here. So we can see that we've encrypted our directory. Our executable doesn't run anymore. Our images don't look like images anymore, and we have weird text inside of this. So now let's decrypt it. Because we're not using a key, we're using the same algorithm. We already know how to decrypt this. So when we go to decrypt this, oh, that was fast. And let's open up secret.txt. Now we see bank details, great, passwords, okay, there we go. Prawn folder, prawn accounts, there we go. Prawn images, we have our little cat image that's visible. We have our executables, and this still works. So we can encrypt and decrypt whole directories now using our very basic encryption algorithm. So now let's do the same thing, but let's add a little key. So I'm going to create a key generator, which is going to take a length. So let's just say key length, and let's make a default to 4. So let's just say 4 is the key length. Now, of course, you'd probably make it larger. Now, what do we want? The key, let's just make it a simple byte array. And, oops, a byte array. And we're going to, in range keylen, so iterate through the range key length, so do it 4 times. We're going to append, we're going to import something else called random. Random is a very useful module for creating random numbers and random items and all of that stuff. So random.randint, and this makes it random.randint, so the randint function makes a random integer. So if you you have the inputs A input and B input, which is basically the minimum and the maximum, and then the output int. Okay. So from 0 to 255. And that's it. Right? Now if we return key, before we execute this, let's comment this out, and let's key equals key generator. I'm not going to put any inputs. I could put the key length, but I'm not going to do anything. I'm just going to print it. If we run this, we're going to have a key, which is, you know, again, a randomly generated sequence. Now let's do 10, right? If we do this, we're going to have a slightly bigger set of bytes. This is going to be our key, but let's leave it at the default value. Now, how do we incorporate this into our file? So encrypt, we need to get the key, right? What can we do with the key? So what I was thinking as the most basic way of encrypting this with a key is, let's say we have a key. So a key has X amount of bytes. So let's use numbers for simplicity. So imagine that each of these numbers is a byte, right? So a key has let's say in this, let's do here actually, it has 4 bytes, right? And what I was thinking is, for each character that you can see, so for each character in a file, you would add the number of that character with this byte. And then for the next one, you add with this byte. And for the next one, we write with this byte, for the next one with this byte, and then for the next one with this byte again. And you repeat it. And you can do this easily. So how would we do this? So we need a count, or in this case, I can call it an index, because it's going to be the index of the key, which is going to start at 0, because we first need the first element of the key, right? Now, we need to okay, so first we need to have, so we have the character, which is our number, right? So let's just delete this. We have our number, and what we want is to add this number with the index. So we're going to add character plus key index, right? Easy. Now we need to change the index. So index equals index plus 1. But of course, it's not just plus 1, because if it goes after 4 or equal to 4, it's going to be out of range. So we need a way to make the index back to 0. So we use the modulus operator again. So we can say that this equals the index plus 1, sure, but modulus of the length of the key. In this way, it's going to be 0, then 1, then 2, then 3, and then when it goes into 4, it's going to be 4 modulus the length of the key, which is going to go back, and it's going to be 0 again, etc. So perfect. So now we have this, and we're adding this into it. Now, obviously, this needs to be appended to the encrypted byte array, and that's it. Easy. Now the decrypt is the same thing, so I'm just going to copy paste this, except it's the opposite. So index equals 0. Of course, we also need a key, and it's going to be called decrypted. So index minus 1, sorry, I'm an idiot, char minus key index. So that's it. That's all we need to do to change the encryption algorithm. And this is why, functions are beautiful, right? If you have one encrypt function, and you change this core encrypt function, which encrypts your data, and suddenly the entire algorithm of all the other functions is just going to work perfectly, right? This is what I love about, functions in general. So key equals key generator. Let's print this key. And the reason I'm going to print this is because I want to use the same key. So this is going to generate a random key. So if I keep printing this as, random keys. So let's copy this byte array. And now let's comment this out and say that key equals this byte array. Right? So we have a random key that is going to be constant, so we can encrypt and decrypt in different stages. So if we encrypt the directory, which we did before, but now let's confirm that everything works. So inside of test, we have a secret with our details, we have the executable, which works, and we have our prompt folder with working images. Oh, also, I needed to do one more thing, but I'll do this in a bit. Actually, I'll do it now, because it's going to be better anyway. usually when you're encrypting and decrypting in the context of ransomware, you usually add another extension to the file. So instead of being created file.txt, you usually add like .encrypted or something like that. That's what we're going to be mirroring, so we can see all files are encrypting. Oops. I apologize. It's connected to power. Okay. I'm sorry, I don't know what happened there. Okay. So how do we take care of this? Well, when we open this, and we can do the same thing as we did before, but what we can also do is we can use another function called os.rename, again from the os module. os.rename takes two inputs, so if you, it takes the destination anypath, the source anypath. So basically we're going to rename our file, is it called file name? Oh, file name, into file name, into the same thing, right? So file name, but with the extension .enc, for example, right? And when we decrypt the file, we're going to do the same thing, but of course in the opposite way. So file name, and it's going to be file name like this, right? Okay. Now in encrypt directory, we also need to do something else. So we want to make sure that when we encrypt something, we don't encrypt something that's already encrypted, because then the decryption will not work, and that we don't decrypt something that is already decrypted. So what we can do is, you'll notice, so, okay, let's do this first. So if you have a file extension, so let's say stuff.exe, right? And then you print a, it's going to be stuff.exe. Now, this works for lists, this works for anything that is an iterable. You can index it, right? So a0 equals x, a1. But what if you want the last one? If you want the last one, you start with negative numbers. So -1, that's e from the exe. -2, that's x. -3, that's e, right? So if you do the colon, with the colon you can specify ranges. So if you do this, it's from all that's before to all that's above, so it's the whole thing. But if you do 1:, it's going to start at the index 1 and go all the way, so tough.txe. If you go from 1 to 2, it's going to be only the one index. This is excluded, by the way. So if you do 1 to 3, it's going to be t and u. So if you do -1 and then colon, -3 and then colon, it's going to output everything from the -3 forward. So from this last e forward, so exe. So what we can do is we can check if file name -3 forward is equal to inc. And if it is, is not equal to inc. And if it is not equal to encrypted, it means we can encrypt it. Same thing for decrypt, except the opposite. So if file name -3 forward equals encrypt, we're going to decrypt it. Perfect. Okay. Oh, and I was an idiot because what I meant was not this, obviously, right? This is the decrypt, so it's going to have everything in till. So if I do the opposite, oops, I meant -4, obviously, because of the dot. I did not, there we go. So if we do everything up until -4, we're just going to have everything but the last 3 letters. And since our extension is going to be .inc, that's 3 letters with a dot, of course, so 4, we're going to go 4 backwards. That's it. So I think this is done. So let's test this out. So now when I encrypt it, oops, oh, I didn't specify key. Of course, we're using a key now. So, sorry, so encrypt data key. The encrypt file also needs a key because it's going to be called encrypt data, and of course needs to pass a key here. Decrypt file name needs key, because of course it's going to use the decrypt function, which needs to pass a key there. Encrypt directory, of course, also needs to get a key because it calls encrypt file, which asks for a key. And I'm just adding all the parameters that are needed. Okay, there we go. Let's try this again. Oops. Line 13. What did I do wrong here? Oh, okay. Of course. Inc number. I'm just going to do this separately so it's a bit easier, so it does not, I need to, obviously, I had the mod before, the modulus before, but I didn't apply it in when I rewrote this, so I need to apply this with, of course, 8 to 156 mod, right? So, and of course, now we need to do this. I could have done it all in the same thing, but it would be too long, so I'm just separating this so it's more easily understandable. And I need to do the same thing here with the decrypt. So we're going to do it here, and this is going to be DEC because it's decrypt, and minus, and now we're going to append the decrypt number. Okay. Everything still works perfectly. Okay. Now let's try this again. There we go. It's all encrypted. Now if you see, inside of this test, everything got renamed to .enc at the end, right? Even if you open this up with, of course, a text editor, you'll see that it's a bunch of bullshit, right? Let's open it with VS Code so it's a bit easier. So you have, so inside of here, so secret, it's a bunch of bullshit. Here, prompt folder, it's easier to see here. So we see we have the enc again, which is just, again, a bunch of stuff. Images, which you cannot open anymore. And of course, even if you change the extension to JPEG, oops, this is not correct extension anyway. If you change it to JPEG, it will be an image, but it won't open, right? Because it's the incorrect format. Now, it's important to keep the enc because the decryption will only work with the .enc, right? Executable, it's all encrypted. Now, let's decrypt this. So we use the same thing, decrypt. Well, I had this commented out for a reason, so. And now we're, oops, oh, of course, I didn't put the key in here. Boom, and it's decrypted. So now if we take a look at this again, there we go, no more .enc files, bank details, secure password. Let's just see if our executable runs. It runs, perfect. And then our image also runs perfectly. Okay. So what we have right now is, oh, and obviously we can only decrypt and encrypt like this because we made our key static, right? If we always had our key in the key generator, then we would never be able to decrypt after we encrypt because we need the same key, right? And yeah, so now we can do this. And you'll notice, like, for example, let's encrypt the whole thing with this key, right? As we did before. So again, I'm just going to test it with the executable, with the files being garbage, right? Now, if we change the key to, say, E4, right? Very minor change, but, and now we try to decrypt it. It will run, but the decryption, it will still not work, right? And all the files will still be gibberish because obviously we did not have the correct key. But you can see that things are actually quite similar to what they were before, right? Banj, Disaler, like it's pretty similar. Why? Because remember what we did, right? We just replaced certain characters with, instead of adding one, we added one of these indexes, right? So not all the letters will be changed. Only one of those letters every 4 letters basically will be changed. So that's why, 1, 2, 3, 4, this was changed. 1, 2, 3, 4, this was changed. 1, 2, 3, 4, right? So you can see how not everything was changed. But of course, for executables, it doesn't work anymore because it's binary data. So it's not a particularly strong encryption. But of course, this can be reversed because, well, if we used this string to decrypt, you can essentially use the same string to, so the idea is, of course, we can make a better encryption than this, and we're going to. But this is just to showcase different ways in which we can encrypt. For this, for example, we need a key, right? And if we don't have the key, all sorts of things will not work. Of course, you can brute force this quite easily, but if you had a longer key, it would be a bit more difficult to brute force. But of course, this doesn't have to be a plus, right? Instead of adding the index, you can do all sorts of operations, right? You can multiply by a divisor and do all sorts of mathematical operations to a number to change that variable so that it becomes very difficult to brute force when it comes a time for it. But yeah, but this is basically it. So yeah, also, yeah, we can try this and then change this again. And now we should be able to, oops, I'm an idiot. I encrypted it twice instead of decrypting it. Well, let's decrypt it. There we go. So now we should be able to use everything. What I did was basically, if I decrypted with this, it means it got subtracted. So then I just encrypted with this, so it gets added. So it's in the same state as before, and then you can decrypt with the original key, right? That's all I did. But yeah, do you guys have any questions up until now? Because I think this was basically the gist for what we're doing today. And I'm going to include all of these topics on the next articles. And I'm going to also make some more videos meanwhile with these as we also expand on this project. Also, I did not check YouTube. I thought I would. I did not. I'm sorry. What did I miss? Damn, never knew Mario was ripped. I'm not ripped. Oh, we're talking about hexadecimal. Yeah. That's neat. Gotta try to decrypt and encrypt stuff. Yeah, it's pretty cool. How does work a complex data type? I've seen the course but didn't get how it works. Oh, okay. So you mean when we're talking about complex numbers, like 2 plus 5j, right? In which, of course, the type of this would be complex. Well, it's the same thing as a complex number in mathematics, right? It has a real part and it has an imaginary part or a complex part. And the operations you can do with it is the same kind of operations that you'd be able to do with any complex number in mathematics, right? So 2 plus 7j times 3 would be 6 plus 21j times 3j times 0 minus j, oops, minus 1j. So the idea is to use a complex number, you have to use some kind of a real number. So real number plus real number prefixed by j. So 10 plus 4j, right? And if plus 0j. If you do just plus j, it will not work because then it thinks that this is going to be a variable. So if you do 1j, it will know that it's, of course, a number, a complex number. But this is how you work with complex data. Hello, Daksh. I'm sorry, I didn't check. I should have checked, but I did not check the YouTube chat until right now. So it's like yielding a value. I'm assuming you're talking about the generators. Yes, the generators is basically the same thing as yielding a value. So if you have a function, so let's call it generator and x, and we're going to for I in range x, yield I, right? Now if we say A equals generator 10, and we say type A, this is generator. If we do next A, 0, 1, 2. This is generator, right? It's the same thing. A generator is exactly the yielding of something. Are there any questions? I'm sorry for the YouTube people that I completely missed. But hopefully you guys get to see this video afterwards. I'm gonna see if there's anything in here. That is very true. Oh, I haven't done I think this one yet. I'm gonna check it out. Okay. Seems like there are no questions for it right now. Let me just look at my stream again. And why do you use VS Code? VS Code? I like it. Oh. Wait, are you asking for what? Like, what do I use VS for? Oh, not VS Code, but Visual Studio. I haven't actually used it in a very long time. I've used it before when I was doing some C# stuff, but that was actually it. I don't actually use it much. It's here because, well, it's here. I use it for the it's sometimes useful also to when sometimes people send me a project, a Visual Studio project, and they want me to check it out or something, and I do it. That's useful. So I also have it. For example, I did it for the crack me's. Yeah, here perhaps login. Go. Oh, oops! I didn't mean to click save. Whatever. The button is right there. Okay, so I uploaded one crack me because I don't know. I felt like it. This crack me, for example, this was built with this as well. It's a pretty cool one. Oh shit! What's the password? I'm an idiot. Wait. Are all the passwords in here the same? I forgot this stuff. I forgot all about this. Oh, there we go. Crackme's.1. Okay. So this one is, well, I might as well. Oh shit! I need the .NET Core. Never mind. I actually did. Wait, this is the same one as I uploaded in my here somewhere. Puzzles, maybe? Somewhere around here? Oh, maybe... Oh, not puzzles, sorry. I think it was... CTF, perhaps. Not that long ago? There's no mark? Okay, wait. No, there is. I don't know where it is anymore. Oh, here. It's a super basic one that I decided to make, and I used it a bit, for example, but other than that, I never use it. But this is a really cool one. You should test it out if you want. It's in the Discord. You open it. It takes a while. You'll realize why it takes a while when you debug this. You tap the code, and it tells you to try again, and of course, you need to figure out what the code is. They have some better debugging options as well. Well, so Visual Studio is really nice for built-in debuggings and all that stuff. With VS Code, you can do that too, but for example, with debug and all of that, like you have a lot of stuff that you can do in VS Code, but to be honest, VS Code is not Visual Studio is a lot better for debugging. It has a lot of options already configured for you in debugging purposes, and it's just a much better experience. I've never actually done debugging with VS Code, only with Visual Studio. So I guess that's what I use it for as well. Yeah, I didn't even consider the debugging part when I was answering that. I should have. So if I use a random key and lose it, I won't ever be able to get my files back. Well, you can, but that's the thing is, if you know the length of the key, right? And let's say the length of the key in this function, right, is 4. But let's say you put the length as 100, right? And let's print the key. All you have to do, so let's run this again. This is a huge key, right? All you have to do is figure out what key it is. If you use a small key like 4, well, this is going to be quite easy to reverse, because all you need to do is make a function that iterates through all combinations of byte array, basically this, all combinations of this. But of course, instead of a random, would be all combinations of it, and then try to decrypt it and see if you get the file back. Now, of course, this only works if you know the kind of file you need back, obviously, right? Because if you don't know what kind of file it is, you don't know if the decryption was successful or not, right? So, because so let's say I have, let's say I'm going to encrypt this with a random key, right? I don't care about this directory because it's not my, it's just a test directory. So I decrypted it with a random key, and I didn't print it. I have no idea what the key is, so it's encrypted. But I'm going to decrypt it with a randomly generated key again. And when I do this, it seems like it's decrypted, right? And it's secret.txt, and it has text inside. But if you don't know that this is not the text that was inside, you don't know if it's the original file. So you need at least one file where you know what's inside, and then you just compare it, right? You just try to decrypt it with a combination, and if the file does not decrypt the correct way, you try another combination, etc., until you find the correct one, brute forcing your way through. But if this is really, really big, it becomes pretty hard to brute force this. Now, of course, there are techniques to brute force it in a better way. So if you know, for example, that it's an executable type, you can check for the first bytes. You can extract those first bytes from an executable file, for example, and figure out if, when you decrypt that with your key, if it returns the bytes that are expected to be in the header of the executable. That way, you only have to compare it to a very small amount of bytes, and it becomes a lot easier. But yeah, you'd have to brute force this, of course. And you, of course, also need to know how the encryption was done, in which this case, it's using that key and just adding a value based on its index. And if you know this, then you can brute force the decryption. And we might do this in a while. But yes, right now, if you do it with a huge key, it will be pretty hard to get your files back if you don't save the key. But by no means is this a good encryption mechanism. This is not a very good encryption mechanism. We will go into other ways to generate good keys and good algorithms for encryption. Maybe even create our own kind of algorithm that is still secure. Because this is not amazing, but it works for these purposes. Anyway, I think that if there are no more questions, this is the end of this particular video. Oops. Oh, there's one viewer now. That's always amazing. Okay, just making sure I got all the chat correct. Thank you for all the subscribers, and thank you for all of the follows. I really appreciate it. I tried not to talk too much. Let's look at a bit of more questions, maybe. I missed some. His spelling is wrong. Okay, I think I didn't miss anything. Thank you, bro. No problem. And I try not to answer too many questions because I wanted to get this full, even though it's already quite long. Maybe do the giveaway today. Yeah, with one viewer, that's going to be quite hard, isn't it? Anyway, thank you guys for coming by, and I'll be ending the stream in 2 minutes, so if there are any questions, you can ask them now, and I'll try to answer them ASAP. Very interesting and informative. Thank you. Really appreciate that. Kind of in a hurry because I'm supposed to go buy Christmas food in a bit, and the store is closing. I'll be looking at your YouTube video. Thank you. Appreciate that. I don't have a good one. You too. Happy hacking. Also, don't forget, and I try to always say this, don't forget, so our website, whitehathacking.tech / well, just whitehathacking.tech, you'll be redirected anyway. We have our courses. This is going to be here. The modules that are going to do with this ransomware project is going to be updated as soon as I can do them. Join our community in Discord, and this is our live stream. And we have some really cool merch. I cannot show you right now because it's washing. I've been trying to use it every day. I have a shirt, a really cool shirt. I have this shirt. We have some new designs coming in, by the way. Oh shit, how much for the course? The course is free. The course is completely free. So this that I'm doing right now is part of the course. The written modules with the next videos are going to be updated here in a bit as well. And all the videos I'm doing is basically for the course as well as a supplement. And the course is really interesting. It basically walks you through the basics of Python. And the idea is to prepare you with basic Python knowledge first. Then we're going to go into C, and then we're going to go into assembly. This is going to create the entire foundation into so that we can go into reverse engineering. I'm a Python noob, so this is awesome. Oh, that's great. So if you want, you can start at the very beginning, where I walk you through the Hello World episode part, then the data types. Now, I must warn you, the videos for the first parts are quite long, and because I just started live streaming and I'm not amazing at editing videos. So for the beginning, at least, the text is going to be a bit more important than the video. But hopefully that's not a huge deal. I'm working on improving those videos. And I'll be doing that next week as well. But yeah, so we're going through all the basic portions of Python, and yeah, and that's it. And it's all completely free. As for our merch, by the way, we have new designs coming in as well, which are going to be quite cool. I'm going to reveal those later. And we will also have a giveaway at some point in the future. So the giveaway will be for something here. I believe probably for the mug. And to enter the giveaway, it's going to be really easy. All you have to do is type a command that I will tell you when the time comes in chat. Oh, the hat is cool, isn't it? And when you type that command, you can use your points to basically buy tickets to enter the giveaway. The more tickets you have, the higher your chance of the higher your chance of winning is going to be. And you get points by following, by staying in chat, by anything you do to support this community in terms of Twitch will give you points. So you get 20 points when you follow, and that will be the minimum amount to that will be how much one ticket will cost, so that everyone that follows can immediately enter the giveaway. And then if you have like 100, you can buy 5 tickets, right? So the more you watch, the more you interact, the more points you're going to get. And that's basically it. Okay, guys. I will go now. Thank you for coming by, and thank you very much for being here and asking the questions. And I hope that this was instructive. And I will be adding the sections, the relevant materials into the course as well. Maybe tomorrow they will be there. Yeah. Thanks for the awesome stream. No problem. Thanks for being an awesome viewer. Thank you guys, and until next time, happy hacking.